So thank you, everybody. I'm Mark Matienzo. I'm the Director of Technology for the Digital Public Library of America. I'm here with Tom Cramer from Stanford University and Debra Hanken Kurtz from DuraSpace. And we're here to talk to you about Hydra-in-a-Box. So each of us are going to present bits of the presentation, and I think we'll have plenty of time for questions and discussion. So we're certainly eager to get your feedback about our project. So I'm going to start by giving a little bit of background on the project. So the origins in the project are in conversations that we at DPLA had with DuraSpace and Stanford about the state of the world of repositories and digital collections in summer of 2014. Through these discussions, we realized that the management and publication of digital collections for libraries, cultural heritage, and memory institutions was at a point where large-scale transition was really possible. A lot of the current repository systems that are currently in use were not conceived with the main objective of putting collections online during an earlier phase of the web, when collections at a national scale were neither feasible nor a priority. Integration with web-based services was novel, and devices such as tablets and mobile devices were considerably even rarer than they are now. Digital content, the curation workflows applied to it, and mechanisms for publishing content to the web have all become far more sophisticated since the advent of these early stage systems. The web has demonstrated its capacity for decentralized discovery, sharing, and reuse of resources across the network. And so we thought, what better way to leverage this possibility than to collaborate together in developing a new best-of-breed system? In addition, DPLA's hubs, which are the institutions that host the material that we aggregate as part of the National Digital Collection, as well as much of the library community in general, lament having to shoehorn the needed functionality into older systems to make this happen. Legacy systems are unable to take advantage of contemporary web affordances to describe, transform, preserve, and serve digital objects to new audiences. For instance, they're often not based on an architecture that can natively support linked data, which is rapidly becoming critical for the cultural heritage sector to manage relationships between digital collections and their real-world context. Conventions and standards such as schema.org and schema bib extend, resource sync, and the International Image Interoperability Framework have emerged and can support many core interoperability needs for digital collections. The issue is that their newness has led to limited implementation in these existing systems without a significant amount of integration work. With almost 2 years of experience harvesting over 11 million items from 27 hubs, DPLA has also recognized that these systems lack rigorous and scalable ways to export their metadata into aggregation systems. This holds equally true for other external applications with which digital collection systems must interoperate, including discovery environments, metadata enrichment systems, content management systems, and crowdsourcing platforms. Legacy systems are also missing reliable and scalable mechanisms to import or synchronize improvements, such as geocoded place names, back from entities such as DPLA. While some institutions have chosen to undertake the development work necessary to address these gaps, many institutions have discovered aging software is also increasingly hard to maintain, given older code bases and architectural assumptions, and painfully difficult to extend, integrate, and build new services upon. DPLA's hubs and similar institutions with major repository needs are using aging tools for the evolving needs of stewarding their digital assets, and for the entirely new job of making digital cultural heritage materials first-class citizens of today's web. Overall, these gaps make management of digital collections and their metadata both more complicated and more expensive for organizations like DPLA, as well as for all organizations seeking to share and add value to their content. In a survey of DPLA hubs conducted late last year, nearly half the respondents noted that they or their partners are considering implementing a new digital collections management system in the future. Several hubs also identified the importance of providing tools that facilitate easy integration of metadata enriched by DPLA back into their systems, both at the hub and partner level. Current systems in use by DPLA hubs and their partners for digital collections management include 47 instances of Content DM, 14 instances of homegrown or locally developed software, and a smaller number of Islandora, DSpace, Omeka, Luna Insight, and bpress Digital Commons instances. Numerous hubs have highlighted that they or their partners were actively seeking to move away from Content DM, but as yet there was no obvious choices in terms of replacement systems. An additional hub noted that their possible move away from Content DM was complicated by the reluctance to invest in the development time and resources to install, configure, and migrate to an immature open source solution. In short, there's a dissatisfaction with the current state of digital collection storage and display, and a great willingness, albeit tempered by the hurdles of any locally created solution, to move to a new environment. So clearly, we think that cultural heritage institutions seem to be actively searching for new solutions that are easy to use, easy to integrate, and offer best-of-breed technologies and methods, matching current web environments and evolving curation workflows. Widespread adoption of new and emerging standards across the DPLA network by current and potential hubs and other content partners will greatly reduce the technical and economic barriers to making their cultural heritage resources easily repurposable, aiding aggregation and discovery, both within and outside the context of DPLA. Availability of a robust, turnkey open source solution for digital collections management will make it both easier for organizations to not only share their content with aggregators like DPLA, but will allow digital collections to be not just on the web, but of the web. In other words, improving and modernizing core infrastructure for digital collections will allow the cultural heritage sector to build on advances of technology, not only in libraries, archives, and museums, but with the web at large. By forming a tripartite partnership to address these increasingly pressing needs, DPLA, DuraSpace, and Stanford intend to produce a turnkey Hydra-based solution for the management of digital collections that can be widely and easily adopted by institutions nationwide. We envision that Hydra-in-a-Box will allow institutions with aging installations of traditional software to have access to a best-of-breed replacement, one that is not only free and open source, but also supported by a diverse, active community. In addition, the product will provide an easier technological pathway for institutions to join DPLA, and will be recommended to new service hubs as well as established ones, the state and regional digital libraries that power DPLA's network. Because this project brings together a number of promising next-generation software initiatives, it can serve as a magnet for additional development around advanced services for digital collections and metadata management. By providing hosting options, this project will enable a simple way for institutions without significant technical staffing or infrastructure to benefit from Hydra and to participate in DPLA. A hosted model also benefits the Hydra project through its expansion of the framework's user base, and also through the potential to broaden the types of interests and capacity represented within the Hydra community. So I'll pass this over to Tom.
So I'm gonna stand up so I can see you and maybe you can see me. Remote does not, okay.
I'll advance for you.
So the remote did nothing?
No.
You're the remote.
I'm the remote.
So DPLA, I think of as a huge bar of nutty chocolate, which it's oh so sweet and oh so promising. And Mark talked about that there are a couple of crunchy bits inside, which is actually gathering metadata and distributing it to DPLA to be the ocean of metadata for the country is actually quite challenging, simply because the people and the institutions that are managing that content don't have up-to-date or adequate facilities. Now, if DPLA is the chocolate, Hydra is, of course, the gooey, rich matrix of peanut butter, which complements it. So how many people know what Hydra is? Yes! Okay. So for those of you who didn't raise your hand, and most of you did, here is 60 to 90 seconds on what is Hydra. So it is, we think of it as three things. So first of all, it is a robust repository that is fronted by highly customized and tailored applications and workflows for different content types. So this is one of the project mottos, is one body, many heads. You have a big, juicy repository on the back end, a lot of food metaphors, I think, perhaps I'm hungry. But then you have these heads that are customized to actually ingest the content and display the content out to users with different needs. Second, from the very early days of the Hydra project, we said, the initial founding partner said, well, we want something that we don't have to roll ourselves. We want a shared technology, so we have all the benefits of collaborative development, but we don't think we necessarily want just one solution to rule them all. In fact, we think one size doesn't fit all, and that's why flexibility was built in at the beginning. However, we recognized how many different flavors of things like an electronic thesis and dissertation platform are there? Are they really that different across sites? And wouldn't it make sense to have what we call a solution bundle And so if University of Hull develops a solution bundle, that University of Virginia and Stanford might both adopt it for theses and dissertations. So that's been an original core part of the product vision. We've begun to see some very promising traction on that front recently, but there's a lot of opportunity moving forward. And then the third thing that Hydra is a community that is actually advancing both the technical framework and working together on things like best practices and methods. And the other project slogan that we've adopted is, if you want to go far, go together, and if you want to go fast, go alone. Boop. So a common reproach, and many of us actually have these in our institutions, is that you have a diversity of different content types. So theses, books, articles, images, AV material, research data, maps, GIS, documents, web archives, you name it. And typically what's happened is that open source communities and vendors have built tailored solutions around one of these specific content types. And you actually get pretty good performance and pretty good functionality for that specific content type. The challenge is we end up running about 8 or 10 or 12 different systems, and they don't actually speak with each other. They have different operating needs in different environments, and you really don't get that scale economy of trying to pull things together. And thank you, Mark. A repository approach is, well, let's think about actually putting all those things into one system that's customized for these different asset types, and has a robust and scalable set of content management systems on the back end, including preservation. And by being able to accommodate these, we can actually meet the needs of our institution. And sorry, I'm not used to this. And in fact, that is what Hydra is. So this is the one body, many heads example. And I think this is particularly telling because one of the results of the survey that we ran earlier this year, which Mark is going to talk a little bit more about later, is many of the institutions, in fact, most of the institutions that are interested in Hydra already have a repository, or Hydra-in-a-Box, already have a repository. In fact, most of them have more than one repository. They are looking at Hydra-in-a-Box as a way to simplify their environment and really to do consolidation. So that is Hydra. How is it going? So those of you, you've seen the presentation before. At this point, there are 30 signed and formally adopting Hydra partners, and they are indeed across the world. In this map, the red dots are partners, the blue dots are known adopters, and the green dots are solution bundle users. In this case, known users of Avalon, a Hydra head and platform built for audio and video material. Thank you. And if you plot, since OR stands for Open Repositories, which was the public debut of Hydra was at Open Repositories 2009 in Atlanta, when we had 4 or 5 institutional partners, and no users, but partners. And as you plot the growth, we see that healthy upward trend, looking somewhat like a hockey stick. But of course, one of the challenges is we know how many signed partners there are because we make them sign paper. We don't know how many users there are because it's open source software. And if you advance, Mark. One of the things that we've done from the very beginning of the project is actually have a fairly strict IP or intellectual property management regime, and anyone who is contributing code to the project actually has to sign a contributing licensing agreement, which basically says they continue to copyright to the code, but they're giving a license and a sub-license to the project so that we, the Hydra project, can use it in any way we want. Back up. If you count the number of institutions that have signed one of these license agreements, there are actually 47 institutions which have gone through the problem of actually getting an executive and general counsel to review this, and there are 180 licensed individual contributors over the lifetime of the project. So this might, in fact, be the best number for the project, but if you advance one more. This is actually remembering that it's a community framework is perhaps the best face of the project. So this was the 3rd worldwide Hydra Connect, which is an annual user group meeting. We had a capacity of 200 people, so it was sold out from 60 institutions that gathered in Minneapolis, Minnesota, not Ohio, in September. And that's copy paste from somewhere else, which I also typed, but that's perpetuating error. And so what we see is there's actually really strength and growth in the community. and the size of the community. It's one of the most exciting things about it. One of the challenges that we've had is when Hydra started, everyone could literally fit into a room and we had these quarterly meetings. That's no longer possible with hundreds of adopters and hundreds of contributors. And one of the most telling successes, I think, for the past year is that we've spun up, taken a page out of other groups and communities' book and started up interest in working groups. So the notion, there's a formal chartering process, but lightweight for these interest in working groups. If there's an individual institution or member that is interested in starting up something, say geospatial interest group, or how do you model GIS, or marketing the project, or migrating from Fedora 3 to Fedora 4, essentially they pitch this idea on one of the community lists, and as long as it's seconded by 2 other institutions, a group is formed. They walk through what are the objectives. If it's kind of ongoing discussion about a set of issues, it's an interest group. If it's a finite set of tasks that are going to be accomplished and done, it becomes a working group. And at this point, I counted, I think we have 18 active groups. We have another half a dozen which have actually already sunset, which is a sign of success. And this is one of the areas where we're seeing a huge explosion in growth, but still managing to make progress with smaller concerted efforts of sub-communities. And one of the things that has often been said of Hydra is, well, it's a framework, which means I actually have to be able to use it, which means I actually have to have fairly sizable resourcing team at my home institution. And while there is some truth to this, at this point, by doing a census of the adopters of Hydra, it's used by large universities, yes, like Stanford. It's used by small universities. It's used by colleges, public broadcasting, government ministry in Australia. It's used by national libraries too. It's used by a national laboratory, Los Alamos, small research labs, a national digital repository, statewide digital libraries, the Rock and Roll Hall of Fame, the Chemical Heritage Foundation, Museum of Performing Arts in Barcelona, and a Shakespeare Festival. So some of these are quite large, some of them are actually not quite large, or they may be a very small part of a much larger institution. So we're already seeing a diversity of adoption. We're also seeing that it's the many heads tenet has really blossomed. So it's used from everything from a self-deposit system and digital collections, the things you might expect, to focus systems for images, media management, media preservation, research data management, digitization workflow, digital archive systems, monograph acquisitions, and other use cases. So it has incredible flexibility. And part of that is by adopting this framework or this philosophy that we call the Hydra Way, which is it is not a directed project. No project director in his or her right mind at the beginning would have said, build a system that does that for all those people and all those different functions for all those different audiences, because the scope would be unmanageable. And in a way, that is very true. By being an open and organic emergent community, we've managed to have a set of developments that we couldn't have imagined if it had been more directed and more centralized. At the same time, it has been an investment in the framework from the very beginning. Contributions back to the core code base is a key tenet of all of the Hydra partners. Partly that's to serve and enlarge the community, but partly that's enlightened self-interest. Without contributing the code back, we know that it's not going to be sustainable, even our local institutions. We've also stressed from the very beginning that it's an investment in a community, not a single project or not in a vendor. And we spend a lot of time making contributions back to the community in the same way that developers make contributions back to the code. So there's an incredibly broad core of people involved at different Hydra institutions in training, documentation, modeling, sharing best practices, and outreach. And in fact, what we're seeing is Hydra adoption at institutions has spread beyond the digital repository group to include subject matter experts in things like geospatial data, repository managers, media librarians, because and archivists actually, because they're quite interested in the model of collaboration that's grown up and they're catching a little piece of Hydra. The last thing I think that has made it incredibly successful is the investment in travel and in face time, where it's the amount of time that group spends with each other. There's 200 people that were in Minneapolis, Minnesota, has really fueled the collaboration. Thorny Staples, who was one of the founders of the project, said, FaceTime fuels collaboration. If you get together, it's going to work. If you don't get together, it's not going to work. And that's something that we're still following. We've also seen some major advances in the technical componentry of Hydra. So Fedora, when we started the project, it was on Fedora 3. With the move to Fedora 4, suddenly a lot more things become possible, including the ease of installation and the flexibility to run a robust system, one of the Achilles heels of Fedora 3. We've also seen the development of things like the Portland Common Data Model, or PCDM, which there was just a session in the last hour on that, which is really trying to identify best practices and common patterns for how you represent your digital objects in a system like a repository, with an emphasis on interoperability and reuse. Sophia is basically a Hydra head that emerged from Penn State. They took their ScholarSphere product, which is an institutional repository. They refactored and generalized it, and now it's become the default starting point for most Hydra institutions. I think there are 38 implementations of Sophia somewhere in the Hydrosphere, and since May of this year, it's been regularly managing sprints from multiple institutions, two-week-long sprints, with developers from 6 to 10 developers in size, and actually with a sprint manager. And so it's one of these things that's grown up organically. We've also seen the development of tools like Spotlight, which is a digital collections and digital exhibit showcase, which intersects, I think, quite nicely with some of the things that we're hearing from DPLA partners. And frameworks like IIIF, or the International Image Interoperability Framework, are beginning to suggest how we might share content in a standard way, image-based content in this case, across multiple institutions or with aggregators like DPLA. Now, all of that said, there is some truth. There was a somewhat famous rant at Open Repositories. The track is called Repository Rants, so it wasn't technically a rant. And it was, it's wonderful that repository systems like Hydra, but not just Hydra, are developing things that large institutions can use when they have significant investment and it's a priority. What about the smaller institutions, the people that don't have the bandwidth or the internal capacity? And how can you actually provide a system that will scale? From a lot of discussions, we've identified that we need a turnkey solution, as Mark said, that is fully featured. And one can argue that within Hydra, there is a full set of features. They just don't all exist in a single product, because they exist in a digital image application, a thesis and dissertation system, an institutional repository. But we, as a community and as a project, have not pulled those together into an elegant single package. We need something that's easy to install and maintain, and we've made good progress on that, but it could be easier. We need something that really concentrates the technical development effort. So as people are developing their different heads on the fringes, we're building back a stronger and stronger core. And finally, and perhaps most importantly, we need an on-ramp for new sites where they don't have to have gone to Hydra meetings for a number of years or have a sizable team. They can install something, get it up and running, and begin to iterate from there. And essentially, what we need to do is, I think arguably Hydra is the makings of a national digital platform, to quote the IMLS program that funded this. But to get there, Hydra needs to build further, and it needs to bundle things in so it's easy to install. And essentially what we really need is a box. So in this project, we talk about thinking inside the box. We've got a bunch of people who are great about thinking about innovative and novel use cases. What we're trying to do is be a counterpart to that and actually focused, concentrated effort to really build a solution that's easy to use and is something that might come out of a more centralized project. And Debra is actually going to talk a little bit about the project itself.
So a little bit about the pitch to IMLS. The management and publication of digital collections for libraries, cultural heritage, and memory institutions are poised for a generational change, and the web has demonstrated its capacity for decentralized discovery, sharing, and reuse of resources across the network. Over the project's 30-month timeframe, we will engage with libraries, archives, and museums nationwide, especially current and prospective DPLA hubs and the Hydra community, to systematically capture the needs for the next generation open source digital repository. We will collaboratively extend the existing Hydra project codebase to build, bundle, and promote a feature-complete, robust digital repository that is easy to install, configure, and maintain. In short, a next-generation digital repository that will work for institutions of all sizes and is capable of running as a hosted service. Starting with DPLA's metadata aggregation services, we will work to ensure that these repositories have what they need to support network aggregation, discovery, management, and access to these resources, resulting in a shared, sustainable national platform. In addition, DPLA will do significant work under this project to plan to further refine its toolset for metadata aggregation and harvesting so that it can be paired with the Hydra efforts. In a prior IMLS grant, DPLA's tech team was funded to move its metadata application profile forward from version 3.1 to version 4.0, which include much richer metadata and linked data, and to begin reshaping the entire ingestion system into a more modular and reusable state. These efforts point toward ways to expand and generalize the DPLA ingestion workflow into an aggregation system in a box, which would be set up as cloud service and hosted for new service hubs and other aggregations across the country. We plan to complete and release this aggregation system in a box, integrating it with Hydra, developing within this project in the timeline of this present grant. Further development of the DPLA metadata ingestion system will allow for support of new and emerging standards not currently supported by DPLA's ingestion process. The intention is to extend the same modular infrastructure that DPLA is currently developing for its new ingestion system to improve aggregation and content management with similar capabilities to define ingestion profiles, mapping, transformation, and enrichment processes, and to generate quality assurance reports. The system will be released under the MIT license, a minimally restrictive open source license to allow for the best possible reuse and contributions. Project partners will use the following metrics to gauge the success of the multi-pronged effort. 1, the overall growth in Hydra community will be measured by the number of partners, known adopters, community email list members, licensed code contributors, code contributions made. The usage rate of the new supported Hydra components as measured by voluntary surveys and registration, the number of DPLA hubs that become new Hydra partners and adopters over the grant term, and 4, the number, ease of transmission, and relative quality of metadata records submitted to DPLA via hubs using the emergent platform, and finally, the number of inquiries and pilot users for a hosted Hydra service. So a little bit about management. The partners bring unique and complementary skills and strengths to the project. Stanford will use its existing leadership in the Hydra project to develop core Hydra components and ensure alignment with the greater community. It will resource product and technical management roles as well as user experience and development. They are motivated to do this because they benefit directly from a stronger Hydra community and a more complete Hydra-based application for use in their Stanford digital repository. DPLA will focus on the development of infrastructure necessary to support metadata mapping and crosswalking the harvesting and synchronization between hubs, partners, and DPLA, and infrastructure to support metadata enhancement and remediation. DPLA will also manage outreach to and analysis of hubs' needs. DPLA benefits directly by strengthening the national network of content contributors and increasing the quality of data and metadata available on the web. We at DuraSpace will use our expertise building repositories at scale to construct the back-end systems for Hydra hosting, enabling the platform to run on cloud infrastructure. We benefit by helping build a more feature-complete Hydra, which serves as one of the principal front ends to Fedora, and by offering the community a compelling and contemporary repository software option. A little bit about sustainability. During the past several years, over 75 organizations have come together to work collaboratively to build a variety of applications under the Hydra project. This new proposed configuration of Hydra will naturally become one of Hydra applications and fit under the current umbrella of its projects. The community of members currently supporting Hydra projects have committed to work together to sustain and advance the projects, ensure all code contributed to Hydra is open source under the Apache license, and use a standard framework to build a variety of Hydra applications. The community is excited about this proposal and new development, and as it will help advance Hydra projects in providing standard, easy-to-use configuration, which is currently lacking across community projects. DuraSpace is a fiscal sponsor of the current set of Hydra projects. We provide a legal home and administrative support for the project. Both the DuraSpace organization and Hydra members will be evaluating the expansion of this relationship in the current year. such that Hydra becomes a fully recognized project under the DuraSpace organization, similar to Fedora, DSpace, and Vivo, which are other open source projects we steward. DuraSpace has many years of experience providing stewardship and sustaining both DSpace and Fedora, and more recently, Vivo. Elements of sustainability include building a robust and engaged community of users and contributors, building a governance model to allow for different levels of participation and decision-making, providing a funding stream to provide any necessary dedicated resources to advance the project, which are not provided through the current volunteer contributing organizations. And over the course of the next several years, DuraSpace will be working closely with the Hydra community to map out a longer-term strategy for ongoing sustainability and support with the help and guidance of the Hydra steering group. We are coordinating a meeting with this leadership in early January, is that right? And this proposed project will directly benefit from the work. DPLA will work directly with its hubs to ensure organizations running those digital libraries can sustain their efforts. Since dozens of the hubs will begin to use or migrate to use the central piece of infrastructure, and given the tightly connected nature of DPLA's national network, there will be strong pressures to sustain the aggregation and metadata enhanced version of a turnkey Hydra implementation. Having a common infrastructure among organizations in the DPLA network is crucial. In addition, DPLA has made sustainability of the central organization and its hubs a top priority in its recently released 3-year strategic plan, which coincides with the terms of this IMLS grant. In the grant, we proposed a tripartite partnership between DuraSpace, the stewardship organization for Fedora, DSpace, and Vivo, and Stanford University, a founder and leading institution in Hydra, and the home of one of the digital preservation network nodes, and DPLA itself. Together, we seek to address the increasingly pressing needs of repository services and to produce a turnkey Hydra-based solution for the management of digital collections that can widely and easily be adopted by institutions nationwide. We will also produce a cloud-ready version of the turnkey application and offer a hosted service both to meet the needs of the institutions without local IT capacity and to help sustain the effort over the long term. Unlike most other current Hydra development efforts, which are typically more organic or locally driven, this effort will be run as a directed project with a unified and integrated project team spanning 3 different organizations and multiple locations. There will be defined roles for a project manager, managing across functional, technical, and outreach activities, and supporting project administration, a product manager who will serve as the product owner for the sprints and determine the product's feature set and roadmap, and a technical manager who will arbitrate direction for architecture and data models and ensure alignment with the community's overall direction. All hands will follow an agreed project plan, product roadmap, and technical architecture as determined by respective leads in order to achieve the more ambitious goals and scope that a feature-complete, easy-to-install, cloud-ready, DPLA-friendly Hydra solution demands.
Bing, bing, bing.
Each of the partners will fulfill specific roles in the joint initiative. Stanford will use its existing leadership in the Hydra project to develop core components. DPLA will focus on the connective tissue between the hubs, mapping and crosswalks to its metadata application profile. And DuraSpace will use its expertise in building and serving repositories, and doing so at scale, to construct the back-end system for Hydra hosting. So the delivers. The impact of this project will be substantial and widespread. First, it will allow institutions with aging software to have access to newer best-of-breed replacement that is not only free and open source, but supported by a diverse and active community. It will also provide an easier technological pathway for institutions to join DPLA. And third, these proposed activities will advance the priorities in Hydra's strategic plan and will accelerate, bolster, and complement development of the open source community. Specifically, Hydra's strategies call for the development of solution bundles, which Tom already talked about, and development of turnkey applications and hosted solutions. Beyond Hydra, sorry, I lost my notes. Okay, so some specific goals. We want to produce a polished, feature-complete, easy-to-install, turnkey Hydra-based application for next-generation digital management, improve and generalize DPLA's metadata ingestion system into an aggregator system in a box, which will lower the bar for DPLA contribution for users of the turnkey system and other Hydra applications. We want to connect these key infrastructural pieces with DPLA hubs, current Hydra partners, and prospective Hydra adopters to create a vibrant, participatory community of adopters and contributors. And finally, work towards a hosted service offering a cloud-based version of the application for use across multiple domains. Okay. So providing hosting options will enable a simple way for institutions without significant technical staffing or infrastructure to benefit from Hydra and to participate in DPLA. DuraSpace will host a version of the turnkey Hydra for its many members or other institutions that wish to move their digital collections to a hosted environment. We currently run other hosted repositories like these, such as DSpace Direct, Archives Direct, and DuraCloud. And we have experience running these services at scale for broad use of users. Similarly, DPLA can work with its constituent hubs to help existing hubs move to a new code base and to provide hosting services for those who can't or don't wish to run them on their own. A hosted model also benefits the Hydra project through its expansion of Framework's user base and through the potential to broaden types of interest and capacity represented by the Hydra community. Okay, timeline. All right, so it's a 2-year project timeline. We're concluding the design process this February, which included collecting user stories, which were gathered by Stanford University libraries. We are embarking on development phase in March, and will continue an iterative development process through November of the following year. We've begun to develop the service and engage with the community, or will. Yes, we've begun to develop the service and engage with the community early on, and we'll continue this work throughout the life of the project. Starting technical work in parallel with user. Okay, so Hannah Frost and Gary Geisler conducted surveys, interviews, and focus groups with stakeholders and shared findings at project meetings in Cleveland, Minneapolis, and Raleigh. Mike Giarlo is currently leading the technical exploration work. The project team is now working on gathering requirements and developing personas to build models and wireframes. And this spring, we will begin work on the visual design. Okay. This image shows the organization of work, much of it concurrent in the design process. So again, this fall, we conclude work on 2 discovery phases and begun work on the technical exploration phase. This work involved in interviewing stakeholders and gathering other feedback via surveys. The tech team also began exploratory work developing core gems. We are currently in the midst of building the information architecture. This work involves developing personas to prioritize requirements and developing conceptual sitemaps, wireframes, and technical prototypes as informed by the personas and community feedback. The preparatory work will lay the ground for development of mockups and a style guide, as well as development of user testing of the eventual project.
So, as Debra said, much of the work that we've undertaken thus far has really been done under the auspices of the design phase. Specifically, the majority of the work that we've done so far relates to the identification and refinement of requirements for the products that we'll be developing. So first, a lot of this work has been undertaking, the work that we've undertaken is to get a better view of the landscape of repository solutions that exist. This includes things like a literature review to examine current trends that exist in requirements, as well as the analysis of existing products and services to get a sense of their feature sets. In addition, we also undertook a survey this summer, which I'll be providing a little bit more detail about shortly. We've also been going a bit deeper into the processes of gathering feedback and identifying potential requirements through holding individual and small group interviews and focus groups. In particular, these have allowed us to have sustained conversations with potential adopters and stakeholders and allowed us to get a more complete understanding of how digital collections are managed in different institutions and why. Through this process, we've also begun to develop a set of defined content types that will serve as potential targets for development. So last July, we issued a survey to understand the landscape of how repositories are used and managed across the profession. We made sure to broadcast widely across DPLA, DuraSpace, and Hydra channels, as well as other channels like DLF. And we seem to think that overall we had a fairly significant response rate of 256 complete responses and 786 responses overall. We've come across a few specific insights. We see a fairly consistent set of expectations across the responses. One is specifically a low barrier to entry in terms of adopting Fedora. There's a strong set of use cases for getting metadata into and out of the system very easily, a need for supporting multiple content types. As we've talked about before, there's definitely a strong need to reduce the need for managing multiple repositories, things like easier installation and customization than existing options, ensuring that the architecture is modular but well integrated, and providing scalability and migration paths for existing applications. In terms of satisfaction levels, we found that most notably, users of hosted systems tend to be more satisfied than users of local deployments. We've also gotten some useful feedback on the types of support necessary for hosted products. We've also gotten some very specific feedback, which I'm not going to go into detail about here, about specific strengths and weaknesses of existing repository options. Most notably, we've got a lot of great information about migration. 53% of the respondents plan to migrate to another system. A lot of those are for a Fedora-based solution, but the rest of those are not sure what's next. Those who indicated that they were going to migrate to a Fedora-based solution, some of them actually indicated they were going to migrate to Hydra-in-a-Box, even though we haven't started actually writing code yet. So that is a vote of confidence in this project, which I'm very happy about. A bit more about the interviews and focus groups. So far, we've completed 21 individual or small group interviews and 4 focus groups. Some of the interviews, or the majority of the interviews actually, have been focused on, generally speaking, repository-related needs, with a smaller subset of those really being focused on metadata aggregation. Since this project is also intended to support DPLA hubs, we thought it was very important to get those, to have those conversations as well. The focus groups tend to be a little bit smaller, and we've held them in conjunctions with conferences like Hydra Connect, the Digital Library Federation Forum, and the Mid-Atlantic Fedora Users Group. The interviews were held either in person or through video conference. For the most part, even the remote ones seem to go quite well, and the focus groups have all been in person at this point. So at this point, we're also basically going through the process of doing additional analysis to further identify the requirements. We're using a coding platform called the Deuce to do this. We've also undertaken some content type analysis. This might be a little bit hard to read, but I think that's okay. But one of the major aspects that we discussed with some of our team members responsible for data modeling is the need to identify salient features for different types of digital objects in terms of their structure, descriptive metadata requirements, the requirements for the types of derivatives that would be necessary, and how the application should behave. We've done a pretty thorough analysis of this. At this point, this is just a preview. This is an internal document, but I'm hoping that we can share this at some point. And this has actually allowed us to start to identify a core set of requirements to what we can prioritize for the first few content types. In addition, we're also in the process of charging a number of dedicated subteams for the project. These are really teams that are focused on specific core areas of work. We have a pretty good number of staff members on this project across our 3 institutions. So I think we've really needed to go through the process to make sure that the roles are clear and people have a clear understanding of what they're being asked to do. So we currently have subteams for design requirements and specifications, a data modeling subteam, a service development, which is both two separate teams for the technical service development and for business development, and a marketing and communications team. So again, part of this is we've needed to do this to coordinate across multiple institutions, and it seems to be working well so far. So this is about all we have, but if you want to know more, we can certainly open it up for questions. But we have a website as well as public contact and information lists. The information list is pretty low traffic, and it's announce only, so feel free to sign up. We are not going to inundate you with lots and lots of email, but we're also working to keep the website up to date. We just published a set of frequently asked questions this morning.
All right, well, we'll be around throughout the rest of the day, so thank you.